Okay, welcome everyone to our next Informix webcast. This is going to be on managing Informix logs, and I wanted to start off with a little demo in just a minute. But it's good to see everybody here. I am Lester Knutsen. I've been working with Informix since 1983, way back in the good old days, and with advanced data tools. Now, the webcast is being recorded, and everything goes well. We'll have a recording up in a few days, plus the slides on our website. Just as a reminder, if you go to our website, under free technical support is webcast replays. That's where you can find all of these webcasts. Second recommendation is please keep yourself on mute. Background noise tends to distract everyone. Also, if you have questions, please use the chat button. And I will try and get to the chat button when I can. When I go full screen like this, I don't see the chat, so I may not answer the question right away, but I'm definitely going to save time at the end of this, and we'll try and get to all your questions then. With that, I'm going to start. This is the next in our series of tutorials on managing Informix logs. And I'm going to talk about the purpose of logs, how they work, what the physical and logical log is, and a little bit about managing logs with Informix HQ. But first, let's just take a quick look at logs. I'm going to give you a quick demo. And I'm going to go to a machine here. The command to see your logs is onstat-L. And this shows me I have 6 logs on this machine. And I'm going to run a little batch billing job that's going to create, and it immediately runs into an error called long transaction. And that's because I did not have enough logs. With only 6 logs, the log filled up too fast for me to even run that job, and it aborted. I'm going to go over here to another machine and run the same job. This machine has 80 logs. Oops, got to be in the right directory. And with 80 logs, it's going to work just fine. So logs are a key part of your Informix environment, and having enough logs, backing them up, is very important. And as you can see, they're going along. If I do an onstat-L, I can see the current log is 240 right here. If I do it again, now it's already 242. So it's going through these logs at a really good clip rate. So that's just a quick demo of what logs look like in Informix. Let's talk about why first. And logs are what make a relational database different from a NoSQL or any other kind of database. And back in the old days when they invented relational databases, they came up with something called the ACID rules. And there are 4 rules for relational databases. All of them have them: Oracle, SQL Server, MySQL, and Informix. The first rule is that each transaction needs to be treated as a unit and either succeed or fail completely. So if the transaction doesn't succeed, it needs to fail and roll back. The second rule is the database has to always be consistent. And that means when you make a change, if it rolls back, it has to go back to the state it was before the transaction started. The third rule is that each transaction needs to be isolated from all the other transactions going on. I have a system here that I will show you real quick with 522 active users running transactions. All those transactions have to be separate and independent and not interfere with each other. That's what isolation means. And you have to guarantee that those transactions happen sequentially, even though it's a multi-user environment. And the last rule is probably the most important, is that once a transaction has committed, it has to be there. If the system fails, you have to be able to recover the system and get back to that last known state. That's a real important rule. Many years ago, I did a benchmark for a company, and we were benchmarking different database vendors. And one of the benchmarks was we set up a 200-user multi-user test, and in the middle of the test, we pulled the power on the machine. And the benchmark was how quick could they recover? And it was interesting to see that the vendors that recovered and those that didn't. And we had one vendor that says, we'd like to skip this test because they know we won't recover. Informix will. And that's a very important rule. Now, transaction processing usually begins with a begin work statement, and then it ends with a commit work or a rollback work statement. A commit work will save that work so it's there, and the rollback work will undo that work and take it back to the way the data was before the begin work. I'm going to talk about the logging modes of Informix, but one key point I want to make is logging is required for all data replication. If you want to have a high availability Informix data replication or enterprise replication, you do have to have logging turned on. Now, what does a transaction look like? Let's just dive right into an example here. You get a paycheck, you go to the bank, you deposit it. Usually what happens is it gets inserted into a deposit table of some kind. And then the second thing that happens is your customer balance gets updated. And so that's a transaction. These are two separate SQL statements that together are a transaction. And I have a begin work and a commit work surrounding them. And you don't want the bank to take your money and not update your balance. That's why this is important. The bank doesn't want to not take your money, update your balance. So both of these SQL statements have to happen. Now, transactions don't happen by magic. They do take programming work here. And you've got to get the programming logic right for this to work. Once I was helping a client debug a problem, and the developer kept saying, the database is not writing stuff correctly. And the database was writing exactly what he told them it to write. He was just not checking his work. After every SQL statement, you have to check the return code. And if it fails, you need to roll back work and out of the function. If it succeeds, then you can go on to the next statement. If that fails, you need to roll back the work and exit the function. If that succeeds, you also want to check the status of the commit work, because this tells you that you made it to the HDR server or not. And if this fails, then you want to roll back the work and go back to before you did the transaction. The developer I was helping with had forgotten all this, and he did an update, an insert, it failed, and then went on and did the update. And so he was missing the insert data because he didn't check the SQL code. So your developers have to do it, and they play an important part in making sure this all works. Now, Informix has 4 database logging modes, and they're all slightly different. Let me describe. The first is the default, and that is no logging. That's the fastest, but it's the least safe. And you cannot use transactions. You can't commit work. You can't roll back work. You also cannot use a no logging database in high availability disaster recovery. Basically, if a no logging database fails, if the checkpoint disk is okay, then you can recover to that. But really the only guarantee is you can recover the last archive. Now, inserts, updates, deletes will all be faster because nothing is logged. And the key to remember here is when you log stuff, it gets written two places, once to the log first and then to the data. So if you have a no logging database, you've got half the log, the writes that you do in a logged database. There are three kinds of logged databases. There's an unbuffered logging database, which is the safest and the slowest, and there's almost no reason today not to use unbuffered logging. Most disk systems are fast enough that there's not a performance degradation with unbuffered logging. There used to be back in 20 years ago when you had slow disk. Data can be recovered from the last committed transaction if the logical log disk is okay, or the last committed transaction on a backup tape or a backup file. And transactions are immediately written to disk in an unbuffered log database. So it is a little bit slower. You need to monitor your logs so they don't fill up so that you have room for your logs. Now, buffered logging pretty much works the same as unbuffered logging, but as the word says, there's a buffer. And the data gets written to that buffer first and then does not get written to disk until that buffer is full. And so you run the risk of losing a little bit of data. Back in the old days, I used to say, if you can afford to lose 5 minutes worth of data, you could use unbuffered logging. But most transaction systems on the web or real-time stores, you can't afford to lose 5 minutes worth of data. So you need unbuffered logging. Then you have ANSI mode logging. And ANSI mode logging is pretty much the same as unbuffered logging, except there's some additional ANSI rules that are enforced. And you're always in a transaction. Every time you start, there is no begin work statement. There's only commit and rollback. And as soon as you commit or roll back, you're starting a transaction right away. So you always are in a transaction. So for most Informix data, what you want is unbuffered logging. This is the safest, and you're using a database because of the rules that get applied in the logging. And this is a way to make sure that you use those well. Now, Informix has two logs. There's a physical log and a logical log. The physical log is a little bit unique. It's an image of a change page in the buffer before it is changed. So an update comes in. Before that update is applied, the page in the buffer gets written out to the physical log. The logical log is a record of all transactions. And so that's the actual update, and it's only the bytes that got updated or inserted or deleted. So it can be very fast, very efficient. It's like the redo log in some other databases. Every database has a logical log of some kind. Now, the physical log is very important for fast recovery. And this is one of the reasons Informix can recover, I think, faster than most other databases. Because when you start up Informix, it looks at the physical log. If it's not empty, it brings that into memory. And then at that point, Informix is at a consistent state as of right before the last checkpoint. Now, because of that, a checkpoint empties the physical log. So the physical log is all changes since the last checkpoint. So the physical log has to be big enough to hold all your buffers since the last checkpoint. And if the physical log becomes 75% full, Informix will then perform a checkpoint to make sure everything is synchronized all right. Logical logs are kind of different. Physical log, there's one. Logical log, there's several. This one system here, I have 6, minimum of 3. And this stores the transactions. So you need to think about this. This actually has the update, the delete, the insert. This is where if you have to roll back, Informix reads the logical log to roll back and undo the changes. And a logical log is free for reuse when it's backed up and it contains no open transaction. So what happens here is I have 6 logs, but look at the numbering system. The current log is, and this is the important number, is the unique ID. The current log is 109. The next log is 103, but it's backed up. That's what this B means, it's backed up. So that when this log is full, it can then use 103. This will actually become 110. And if I issue an onmode -L command, we'll see it actually changed. Whoops, there've been more numbers, more logs have been used since I did that, so my data was not fresh. I'm now at log 125. If I do another onmode -L, change logs, and now I'm down to 126. And what happens is when it gets down here to 127, let's just do a couple of onmode -Ls to get it down. Now, if I do an onmode -L, it's going to wrap. And the first log in the list becomes the next log. And it can do that as long as the logs are backed up, and all of these are backed up and free. If all the logs are full, the server will hang. And that's a real problem. You either need to add some more logs, but this is the catch. It takes log space to add more logs. And the other option is to call IBM support, and they can usually come in and fix that by truncating the logs, and you will lose all your data that was in the logs. Now, there are some parameters in the onconfig, and let me go through them real quick. The first parameters are for the physical log, and my 2 cents is don't mess with them here. Use the onparams command, or I'm going to give you a command later on to increase the size of your physical log and move it out of the root DBspace, and that will update this for you. So you need the physical log. You can control that with the onparams command, and that's the better way to do it. You need a physical log here when you first start Informix. It's in the root DBspace, and then you can change it later. The physical buffer is a buffer in memory where data gets written to before it gets written to the physical log. And I'll show you that in a minute and how to monitor that, because that can be a key performance tuning. Just remember that the bigger you make this, you run the risk of stuff not being written to disk and memory failing. Logical logs. This defines how many log files you have and the size of those log files. Again, you can override this with onparams, and that's the better way to do it. There's a parameter called dynamic logs. And 2 here is automatic, which means automatically add logs if necessary. Now, that's a great parameter, but it doesn't quite work the way you think it does. I keep it at 2 as a good default, but you need to be prepared for the fact it can only add logs if you have space. And the other thing, you notice when I ran this benchmark earlier, it didn't add logs fast enough. It added 1. I went from 6 to 7, but it still rolled back the transaction because my logs were too small and it couldn't add them fast enough. So there are a couple of factors to this automatic log. What I like to do is create my logs, fill up the log space, and then there's no room to dynamically add logs, but then I've got plenty of logs. The last parameter here is the log buffer. And this is a buffer, again, for the logs. And in buffered logging, that buffer gets full, and then it gets written to disk. In unbuffered logging, that buffer gets written to, but as soon as anybody does a commit, it gets written to disk. So the buffer is only used for uncommitted transactions. Now, how do you monitor logs? onstat-l is your key tool for that. onstat-l shows you what your logs are. And the flags will tell you if they're used, if they're backed up, current, and last checkpoint are the other 2 flags here. And I'm going to flip over to one of my other systems that has a couple of logs. You can see here my current log is 830,312. And as soon as this becomes 100%, since this is backed up, this will be free to use. Now, key things on the onstat example that I want to point out. And let me just, and I can show you that. Pages per, this tells you how effective your buffer is. I have a buffer size of 64, and I'm doing 61.12 pages per IO. That's a good buffer. And if this was 20 pages per IO, I'm wasting space with this buffer size. If this was 64 pages, that means I could probably make the buffer a bit bigger. That's a good indication of how your physical log buffer is doing. The second one is the logical log buffer. And pages per IO here is 4.6. My buffer size is 32. That's because this database is using unbuffered logging. So having a big buffer isn't really going to help a lot because every time there's a commit, it's going to get flushed out of disk. Now this is the default, and I normally would not change it and make it smaller, but just keep that in mind. If you do make this bigger and you have unbuffered logging, you're not really helping anything. A couple of other things to point out here is the physical log begin tells you what DB space, what chunk that log is in. So this is in chunk 1, which is root DB space. Your logical log begin tells you what chunk the logs are in. And so these are all in chunk 2, which happens to be my log DB space. If I do an onstat-d, you can see that chunk 1 is my root DB space, and chunk 2 is my log DB space. Very good way to tell where your log. Now, another key measurement of logs is onstat minus that, because it tells you transactions are using what logs. And let me go back to the system right here, which I have 500 users, do an onstat minus X, you can see I've got just a lot going on. And one option I like to do is onstat minus X, and I grep for B. B is begin work. Please tell me all the transactions that right now are doing the begin work. And it tells me how many logs they have, what log they're in, they started in, and what log they are currently in. So if you see, we've got 80 logs here. So I saw a transaction that had 40 logs between the two. That would tell me I'm about to have a long transaction. This is a great way to monitor your logs. They're performing. And it's really how your transactions are using your log. Now, you can take this address here. Let me do onstat minus X, and I'm going to do a head so you can see the this address here, this field here is the address of the user that is managing that log. And so if you do an onstat -u and grep that address, well, that user has gone already. But if you grep for the address here, you can find which user, I'm sorry, this address, that's the address. This is the address you want. User thread address. So onstat -u, grep for the user thread, and that will tell you the user that is running the thread. So log performance. How do you know how many logs you'll need? And how, particularly for HDR, this is a very good indication of how much data to go over to the secondary. If you have 80 logs, it takes you 4 days to go through all 80 logs. That means every 4 days, you're going to send those 80 logs to the secondary. A key metric is my log. I'm going to go over here to a server and onstat minus. Let's just run this benchmark, and I'm going to create a work here. It's going to do a bunch of inserts. It's running billing job, and do an onstat dash all. It's probably way up here at the top. There is the current log. There's a current log. I have a script here I want to show you that I use to measure. And this script is actually the next slide. I use to measure my turnover rate. So I ran the script. It reads this master database. It tells me I have used 79 logs. It tells me I used those 79 logs in 55 minutes. I'm in a 0.4 logs. 0.4 of an hour. And it's telling me I'm using 82 logs per hour. And it tells me how many pages. And you multiply that by your page size, and that will tell you how many bytes are going to be transmitted to the secondary or RSS server. This tells you your log turnover ratio. This is terrible. I'm going through 182 logs an hour. One, that tells me my logs are too small. And two, if I'm going through those logs that fast, I'm going to miss my two goals here. And my goals are to have enough logs for 4 days. And because back in the old days when I used to back up the tape drive broke, I wanted enough logs so everything would work over a 4-day weekend and I wouldn't have to worry about it. You want enough logs so that things can run for a long period of time, because if they stop getting backed up, the server is going to hang. The goal should be to turn over about 12 to 24 logs per hour. And that's telling me I'm turning 180. My log is way too small. I need to make bigger logs. Now, bigger logs means it's going to turn over less. It will actually perform better because changing logs takes a bit of overhead. So you want to keep your logs to a reasonable size. Now, if you make them too big, and this is the downside of making huge logs, I did a benchmark once. It was the best performance I ever got, and I had 3 huge logs. Is safety. Is with those big logs, you're going to be backing up less often. What you want to do is back up those logs as soon as you can. And so the goal is, I think, to have about 12 to 24 logs every hour, once every 5 minutes. That way, if you back up your logs every 5 minutes, you know that if you had an absolute disaster, you could recover to at least 5 minutes ago. This is the log performance I showed you earlier. And here's the output. Here's a version when it's doing 37 logs per hour. It's a bit more reasonable. To when logs are not backed up. And this is a good one to put into like a cron job run, because you only want to see one log not backed up, and that is a current. And this you want to see one log not backed up. If you see more than one, you have a problem that your logs are not being backed up, and you need to go check on that and figure it out. So it's important to log for your logical logs. If the log backups fail, the server will hang. If all the logical logs are full, the server will lock. And likewise, if you have a long transaction, that transaction will roll back. It's still going to need log space for users doing the rollback, because the rollback itself takes log space. Now let's talk about long transactions. There is a parameter in the onconfig file called LTX-HWM and LTX-HWM. This is the definition of a long transaction. And this is one user taking 50% logs. Informix will roll back their transaction, abort them and roll them back. And that's because if it let them keep going, they might fill up all the logs and lock the whole server. So it's better to roll them back. At 60%, because the rollback does take logs, and it hasn't reached the rollback at 60%, it goes into an exclusive mode where Informix stops everything else and focuses on that rollback. Now the defaults, my onconfig file. Anyway, the defaults I've set them to 50 and 60. The defaults are much higher than that in most Informix systems. And I would really recommend setting them at 50 and 60. Yeah, one of the reasons they make them higher is because of that automatic log feature, which is great. But you got to have space free to add logs for that to work. And your logs have to be big enough that you're not going through your logs so fast for that to work. Now, checkpoints. Checkpoints are a key part of logging because, and that's the main reason of the physical log is to store pages that change before a checkpoint. And this sets a recovery point for when Informix starts up. Every time you have a checkpoint, it syncs everything in memory to disk. And then it marks it in the logs that I just did a checkpoint. So this point in time, everything is synchronized. And then it clears out the physical log and starts over again. Now there's three types of checkpoints. There's a full or synced checkpoint, and a full checkpoint blocks all transactions. If you have version 9 or 10, there is a fuzzy checkpoint, which is not very good. And there are a lot of problems with fuzzy checkpoints. In fact, I would recommend if you had version 9 or 10 to turn them off. If you have 11, they came out with non-blocking checkpoints, which have been very successful. They still block, but only for a small fraction of time to synchronize everything. Once that synchronization is done, everything is unblocked and everything goes on. So what happens in a checkpoint? First thing is Informix locks everything so that it can take a snapshot. And this is sometimes if you have a user in the middle of a transaction that's rolled back, you'll see the message checkpoint required, but it can't start a checkpoint. And that's because it can't lock things and it's waiting for that user to finish doing a critical section of code means doing an insert, update, or delete. Once that is done, then it flushes the physical log buffer to disk. Then it starts writing data out, and it keeps going until everything is flushed to disk. Once everything is flushed to disk, you can continue online. Now, if the physical log becomes 75% full, Informix has to do a sync checkpoint. If you issue an auto command or shut down the server, it has to do a sync checkpoint. Some administrative actions like adding DBspaces will cause a sync checkpoint to happen. A restore operation will cause a sync checkpoint to happen. The end of fast recovery or full recovery will cause a sync checkpoint to happen. So there are good things to happen. How do you tell the performance of your checkpoints? And I'm going to cover this real quick. If you do an on minus G CKP, this will show you your checkpoints. Now let's see if I can make this a little bit bigger. Why I had a checkpoint because I had a long transaction, a log checkpoint. Here's a user checkpoint because I issued a command. The key thing is the block time. And that's this column right here. And that tells you how long were things blocked. Most of the time it will be 0. Let's go to one of my other servers. This one's fairly busy because I've got 500 users on it. I've got no block time here. And that's what you want to see. No block time on checkpoints. I'm going to show you to monitor your checkpoints. This basically is called checkpoint summary, and you run it, and it takes a look at the last 20 checkpoints, tells me they're all non-blocking, and it gives me an average of the time, and it gives me an idea of how much data was written out, how much critical time, and these are fractions of a second. So there was basically very little time in this checkpoint. And this is a script right here in the slides, which you can get from the website later on. Here's an example. I ran the same script on another server. I have a blocking checkpoint and a non-blocking checkpoint. So I had 8 blocking checkpoints here, 20 non-blocking checkpoints. And it gives me an idea of what was happening and the time for those blocking checkpoints. I also have a script here that will show you your last 10 checkpoints, much like onstat-g CKP does. Now, backing up logical logs. This is really important. If you don't back up your logs, they fill up and your system hangs. You can use OnBar or Ontape. And Ontape, this should be C, not L, I just realized. Ontape -A or Ontape -C will back up OnBar -B. Now, in order for backups to work, you have to set LTape device, this is for on-tape backups, to a directory or to a tape drive. If you set it to dev null, and this is the default on some of my systems, this one is being backed up to a device. But if you set it to dev null, the logs are going to, basically you're throwing away the backups. The logs are going to be freed immediately and they're not backed up. This allows you to use logging, but it really doesn't work. What I think is the best practice, and this is what happens when you set it to dev null, the logical logs are basically thrown away, so you can't recover from them. But it does allow you to run things with logging. It does allow you to do HDR and various other things like that. There is also an OnBar command to back up your logs to dev null if you need to do that. Now, Ontape -C is called continuous backup. Nobody uses this much now. This was designed for the old days when you had a tape drive, you stuck in the tape drive, and an operator would type Ontape -C, and that would sit there and back up the tapes all day. And when the tape got full, it would prompt the operator to change the tape, stick a new tape in, and it would keep going. Ontape -A, I like to call a manual backup. They call it automatic. It only backs up the current logs. And every time you do it, you've got to put in a new tape drive if you're using tapes. That's why it didn't work very well with tapes. But it works great with directories. And what it does is it allows you to back up logs to a directory that Informix sets up and manages. And then you can take those directory and copy them to a tape drive or to some other system. I like to rsync them up to another system if you're on tape -A. Now, to back up to a directory, you need to set LTape device to a directory. And I showed you an example of that right here. This is to a directory. So I have a directory called backup, Tiger 4, because that's the name of the machine, L logs, and they're all my backups. From that directory, I can have my big NAS backup system, or I can rsync it to, what I like to do is rsync it to another server someplace or to the Google Cloud, whatever you want to do. And you can get this to run automatically using the alarm program. Let me give you an example. I'm on log number 318311. If I do an on mode -L to change logical logs, you can see it just backed up a new log. And it's smaller because it wasn't full. And if I do that again, it just backed up a new log. And that's because I'm using the alarm program to back up logs. Let me show you how that works. In the alarm program, by default, it's turned off, but there is an option at the very top to say backup logs equal Y. And then there are a series of commands down here. And the default is to use OnBar, but you can also use Ontape. And if you use Ontape, you want to be sure and say Ontape -D -A -D. The -D tells it that it's going to be run in the background. If you don't do that, if you just say Ontape -A, and Ontape is going to sit there expecting a prompt, and there's no one there to give that prompt because the alarm program runs as a daemon in the background. Every time an event happens in Informix, the alarm program gets called. Most of the time it does nothing. But if you do this, it will now automatically back up your logs to a directory. And then you can rsync or copy these logs offline. And you really need to do that to be safe, is copy these. What I like to do is have a program that does an rsync of this directory maybe every 10, 15 minutes. Now, the purpose of all this is to help Informix a faster recovery. And let's say your server crashed. How do you get it back? Fast recovery is automatic. It's not something you start up. Every time you start up Informix, it goes automatically into fast recovery. And the first thing it does is it looks at the physical log and says, is there anything here to recover? If there is, it will recover it. And then it looks at the logical logs and says, is there anything here to recover? And if there is, then it will roll forward all committed transactions. So the physical log is going to recover it to the state of the last checkpoint. And now the logical log is going to roll forward to any transactions. And then it's going to roll back any uncommitted transactions. It's going to undo any uncommitted transactions. And if Informix is shut down correctly, there should be nothing to do here. It goes into fast recovery every time it starts up, but it'll have work to do. As an example, if I look at my message log, and I just did a search in my message log for fast recovery, And you'll see these messages every time Informix starts. And this says it started fast recovery, it started physical recovery, and there were 8 pages in my physical log that needed to be restored. And then it started logical recovery, and there were no pages in that log that had to be restored. So everything was good. That happens every time in Informix. And, now, Informix HQ. This is the last bit I want to talk about, is using Informix HQ to manage logs. And it's a great tool. It makes it much easier. This is Informix HQ. And I'm on a server called Tiger 2. This is the one with only 4 logs. Now, logs are where they would be under storage, under recovery logs. I would have thought they would have been under logs. They're under recovery logs on storage. And this will tell you where your logs are, how many logs you have, what percent is used. And there are a couple of commands up here. Like I can logs. Now I've just switched to a new log. You can see that the current log is different. You can also add a log, and it will ask you what DBspace do you want to add a log. Let's make this 20 megs, and I'm just going to say add, and it added a new log here. So this makes it much easier to manage your logs with Informix HQ. You can see your logs, you can manage your logs. Let me take a system that's busier. Let's go to Tiger 4 and come down here and look at the logs. I've got pages of logs here. I've got 4 pages of logs because this system has a lot. And I can just flip through those pages. And as you see, this tells me that, okay, all my logs are backed. I've got 1.5 gigs of logs. They're all backed up. Nothing's free of the logs, but they're rolling. So that's how you use Informix HQ. It makes life a lot easier to manage your logs. Now, like I said, you can also use on-params, and this is really what I recommend doing, is after you've started your server, and if you guys were on the webcast I did a couple of weeks ago on the configuring a big server, you would have seen the scripts to do this. You can move the physical log out to a new DBspace, and you can add a bunch of logs with this. Key thing to remember is that 30% of your writes are going to be to the physical and logical log. In fact, I've even seen it go up to 50% of your writes. A lot of data needs to get written out to logs. So the disk you have these 2 devices on, these 2 chunks on, is very important. You want them on a fast disk for writes. And your physical log, you want that to be sized at about 1.25 times the size of your buffers, so that it can hold all your buffers being full without causing a checkpoint. And the reason is 1.25% is because 75% will cause a checkpoint. So that's the size for the physical log. Here's a script to actually use on spaces with the new -p option to, and this was from my setting up a server script a couple of months ago that I showed. So I'm creating a DBspace. -p says that's a physical log DBspace, and I'm going to move the physical log there and use all the space for it. Very simple, one step to move your physical log to a new DBspace. Now, your logical log, You want to also move out of the root DBspace, and you want to have your log size to hold 5 to 10 minutes of transactions at peak load. So don't make them too small, because then you'll go through logs very fast. And there is a bit of overhead with going through logs very fast. If you make them too big, then you're not going to go through logs very often, and you run the risk of, if you have to recover, not having the logs available for recovery. And it's a good idea to have 4 days of logical logs. I see most of my production sites have thousands of logs, and that's a really good idea. Now, a really good practice is to have 2 DBspaces for your logical logs. And the idea is to alternate your log creation so that one gets written to, the second one is then backed up. And after this is finished backing up, the log could then start writing to the second DBspace, and the backup will go from the first DBspace. Now, the way you move the logs, there is no move log command. You have to create 6 new logs. You have to make one of the new logs the current one with the last checkpoint, and then you have to drop the old log. This is sort of the syntax I use for that. I'm creating 6 new logs in a new log DBspace. You notice I'm alternating between the 2 DBspaces every time. Then I issue a bunch of onMode-L commands, onMode-C to perform the current checkpoint. So now I'm in one of these new logs. Then I can drop the original. And then I have a little loop, and you can make this as big as you want. I've made it up to 1,000, depending on how many logs I'm trying to create, where I just alternate creating logs in these DBspaces. So just in summary, I am going to talk about this. Logging is required for any kind of replication, HDR and enterprise replication. It's required for SQL transactions. The best practice is to move your physical log out of the root DBspace and move to make it 1.5 times. I said 1.25 earlier. I actually like it bigger. The size of your buffers. And you want to move your logical logs out of the root DBspace. And then you want to have enough logs for 4 days. And you want to do about 6 to 12 logs per hour. And you want to make sure you have automatic backups set up. Questions? Let's take a look at the chat now. Okay, I'm going to start with Raj. I don't know the max size, but I think it's really dependent on the size of your DBspaces. And I'm not sure I'd want a 2 gig logical log. So the question here is in 14, what's the max size of a logical log? Big logs are fast for benchmarks, but aside from benchmarks, in real life, having 1 or 2 or 3 big logs is not very practical. You want your logs sized so that they get backed up about every 5 to 10 minutes. An earlier question is, someone says we're using Ontape-C backing up to disk. That works. What you have to remember, though, is if you do a Control-C with Ontape-C, you better move that disk file, because the next time you do an Ontape-C, it's going to overwrite your backup. And you will then lose that backup. It doesn't append to it when you do Ontape-C. It starts over and overwrites it. That's a very good question. Yes, 1.5. So the question is, physical log buffer size should be 1.5 times the buffers. That's the total number of buffers. And if you have 12K and 4K and 2K buffers, you need to add them all up. ER should be big enough to hold 4 logs per hour. I think it's kind of small. If you have a log every 5 minutes, that would be 12 logs. And that to me is about the perfect size of your logs. So they're big enough so that you have one every 12 minutes. All right, now you may have performance problems, which is why they told you that, Raymond. Last question there. Yes, the slides will be available. Check back on Monday. And if you missed it earlier, here we have webcast replays. So if you get tired of Netflix, please go watch our Informix webcast. So a couple of quick things to wrap up, and then I'll take any more questions. If you're not a member, please go join the Informix user group. One thing I really like is the Informix online community. This has replaced the old Informix mailing list. And this is a good place if you have questions to go ask your questions. And there'll be a link in the slides. Just go to iiug.community.org. It's run by IBM. There's a lot of good information here. I really appreciate it. Next webcast is going to be on May 28th, and we're going to talk about Informix backups, recovery, and HDR. And then we have another webcast in June on connecting to servers, one in July on tables, and then one in August on monitoring. My goal here is to give you guys a taste of what our webcasts are like. Now, if you're upgrading to 14, we have a course for you. We still have some space in our May course. Since the course is now only online, I moved all the servers in here to the training room. So we have all the servers up here. Each student gets their own server. So if you mess up your server, you don't mess up anybody else in class. Class size is limited to 8 students because of that. And we're going to cover everything about 14, upgrading to 14. Last year, I was really shocked. The first time I did this, just after 14 came out, we had 2 students go back and upgrade to 14 on their own very successfully. So this works really, really well. And I think that's the end of questions. I want to say thank you guys for everybody that participated in this. See you next time. With that, I'll end the presentation. Thank you all. Have a good day.